Hey guys, I got a question to post another video about how to do the exponential functions matching. And so I hope this video will be a little bit more helpful for you guys. So I just pulled up an example of what you guys will be seeing on that first assignment, assignment number 1 for this week, which both of those assignments are due on Friday at 4 p.m. So it says which equation matches this graph, and then you're given the equation. Down here on the bottom is your answer choices, and then you're given the graph. And so what I've done is I've written out on the other side of my notes from yesterday is I just wrote out a little cheat sheet for you guys. So a couple of strategies that you could use to solve this would be to graph and match. So to graph the equations in Desmos and match those. So let's do that as the first example. So -4 1/4 to the x minus 1. So I've pulled up Desmos. Y equals -4 parentheses 1/4 to the x, too many parentheses, minus 4. So now I can look at this graph. Does that look like, oop, it's minus 1. Does that look like this graph? Nope. So I can eliminate that answer. That's below the graph. Let's do +1. Let's see. +1. Yeah, that kind of looks like that one. So I'm going to hold on to this one. So then I'll do -4, and then instead of 1/4, it's 4 to the x minus 1. That doesn't look like that one. And then -4 to the x plus 1. Oops. And my graph doesn't look like that one either. So my answer was this one. So you can graph and match, which I would do for this one too, especially if you're given the equation. Which graph matches this equation? -4 1/2 x plus 4. So now I'm going to be looking for a graph that looks very similar to this at the asymptote of 4. So let's see. I can eliminate this one. I can eliminate this one. And it's going to be this one. It's the one that looks the most like. The other strategy that I've listed on my little cheat sheet is to match the characteristics. So if this is your basic equation, a times b to the x plus c, c is going to be your asymptote, so that's going to be where your dotted line is. Your b value, if it's growth, is going to be greater than 1, which means that it's going to look like this, increasing, going up. And decay is going to look like decreasing, going down. If my a value is positive, it's going to look like it's above, above the x-axis. If my a value is negative, then it's going to be below, typically, the x-axis, or it's going to look like it's going down, so it's going to be on the bottom half. So this is a little cheat sheet, so you're welcome to screenshot that, or welcome to pause that and have that up next to your screen. But now let's take a look at this example, and let's see if we can match the characteristics. So I have a negative a value, which means that it's going to be flipped downward, so I can eliminate this one right here, and I can eliminate this one right here, so these two are gone. My 1/2 is my growth or decay factor. Well, to be perfectly honest with you guys, it's hard for me to tell when they're flipped downward what it's supposed to look like. But I know that my +4 is going to be my asymptote value. So that means that my dotted line should be at 4. Okay, well, both this one and this one have asymptotes at 4. So that means that I'm just going to graph and check. So I've got -2 1/2 x plus 4. Okay, so it's the longer tail is going to the right. The longer tail is going to the right. Okay. Let's see, I'll do one more. Which equation matches this graph? Okay, so my asymptote is at -1. Okay, well now my C value is -1 on all of my graphs. My value should be negative because it's below, it's going down. So that means that I'm either down to this one or this one. Now it comes down to the B factor. So now I'm going to just graph and check. So I've got -4, 4 to the x minus 1. That one looks a lot like that one. Let me try one more, the 1/4 instead. Nope, that's not that one. So that's my answer. Boom. Okay. Thank you to the 27 of you who have already done that so far. Great job, guys.